So this is possibly the final video of the half term, and the chapter that we're going to be covering is about indices. Okay, so indices, you should have lots of prerequisite knowledge, so things you already know from low remove. So I'm going to run through some of those. This should just be a reminder. You have covered everything in this chapter. You just might have forgotten. So we have something like this rule: x to the a times x to the b. Pause the video. What is it? It's x to the a plus b. For example, 2 squared times 2 cubed is 2 to the 5. This makes sense because you're allowed to do this when the base is the same. So the base is the same, i.e. we've got the number 2 in both cases. You wouldn't be allowed to do something like 3 squared times 2 to the 4, for example. Okay. New rule: x to the a divided by x to the b. Pause the video, see if you remember what that is. So that is x to the a minus b. For example, 2 to the 5 divided by 2 squared. Wow. We can think of it, the answer is going to be 2 cubed, but if you want a little explanation, 2 to the 5 is 2 times 2 times 2 times 2 times 2, divided by 2 times 2. This 2 cancels with this 2, etc., etc., leaving you with 2 cubed. Okay. Next rule: x to the a all to the power of b. What is that? It's x to the ab. For example, 2 squared all cubed. Okay. There's going to be 2 to 6. Here's a quick explanation of why. So this is 2 squared cubed is what it says: 2 squared times 2 squared times 2 squared, 2 squared cubed. 2 squared times 2 squared times 2 squared. We know that when we multiply indices with the same base, we can add them. So this gives us 2 to the 6. Okay. An example of something similar . So if we have 3x squared all to the power of 4, pause the video, see if you can work out what that is using the rules. Okay, well this would be literally 3x squared to the power of 4. So 3x squared times 3x squared times 3x squared times 3x squared. Okay? Now 3 times 3 times 3 times 3 is 3 to the power of 4. There are 4 3's. And x squared times x squared times x squared times x squared is x to the power of 8. You could simplify this if you wanted to as 81x to the 8. Okay, now you could have written the answer straight away if you wanted to. I just wanted to highlight the point that it's 3 to the power of 4 times x to the power of 8. Some people will ignore the 3 to the power of 4 and just write it's 3x to the power of 8, which of course is wrong. Okay. Right, so these are some of the simple rules that you already know. Let's move on. Okay. X to the power of 0. Anything to the power of 0 is 1. For example, 2 to the power of 0 is 1. Okay. X to the power of 1 is itself. 2 to the power of 1 is itself. Okay. Brief explanation of why this is true, and this will help us looking at negative powers. So let's look at 2 cubed, 2 squared, 2 to the 1. So what happens from 2 cubed to 2 squared? Well, we divide by 2. So it makes sense that going from 2 squared to 2 to the 1, we divide by 2. So 2 to 1 must be 2. 2 to the 0 then, using the same rule, we divide by 2, giving you 1. Some people will write 2 to the 0 is 0. It's of course not. Okay. Using this idea, using this pattern. This now leads us on to negative indices. What happens if I carry on? Well, this must be 2 to the power of minus 1. 2 to the power of minus 1, well, I divide by 2 again, you get a half. 2 to the power of minus 2, divide by 2 again, you get a quarter. 2 to the power of minus 3, divide by 2 again, you get an eighth. Notice how an eighth is 1 over 2 cubed. Notice how a quarter is 1 over 2 squared. Notice how a half is 1 over 2 to the power of 1. This leads us to a rule with negative indices. So with negative indices, x to the power of minus n, pause the video, see if you know what it is. Well, it should be 1 over x to the n. Okay. This here on the left-hand side is what we call index form. Index form. The right-hand side there is called fractional form. Okay. Examples of using negative indices. A complicated example: 3x squared to the power of minus 3. So, we know that is going to be 1 over 3x squared cubed using the negative indice rules. 1 over 3x squared all cubed. Okay, well that's going to be 3 cubed, which is 27, times by x squared cubed, which is x to the 6. Okay. Another example. 3 over 2 to the power of minus 2. So we could write this, we can do it in two ways. We could write this as 1 over 3 over 2 squared, which is 1 over 9 over 4, because 3 over 2 squared is 3 over 2 times 3 over 2. 1 over 9 over 4 is just 4 over 9. I'll explain why that's true soon. You could have also written 1 over 3 over 2 squared. We could have said it's 2/3 squared. Okay. So the path you could have taken, if you wanted to, you could have said 3 over 2 squared equals 3 over 2 to the minus 2, sorry, is equal to 2/3 squared. 2/3 squared is 4 over 9. So why is 1 divided by 9 over 4 4 over 9? 1 divided by 9 over 4, we flip the second fraction in times. So 1 divided by 9 over 4 is 1 times 4 over 9. Okay, let's go back. Great. So I'm going to pause the video now, come back to it in a bit, go get a cup of tea or something, and we're going to move on to fractional indices. So fractional indices, x to the power of m over n. Okay, you've done this before. This is the nth root of x to the power of m. A way to remember this is flower power, the number at the top, the numerator there is the power. The n there, the number at the bottom, is the roots, flower power roots. Examples. 9 to the power of 3 over 2. This is the square root of 9 cubed, which is 3 cubed, which is 27. 16 over 81 to the power of negative 5 over 4. Now the negative sign there, we flip the fraction. We do 1 divided by 16 over 81. Okay? So this gives us 81 over 16 to the power of 5 over 4. So that negative kind of flips the fraction. Okay? So 81 to the power of 5 over 4 is 81 to the power of 5 over 4 divided by 16 to the power of 5 over 4. 81 to the power of 5 over 4 is the fourth root of 81 to the power of 5 divided by the fourth root of 16 to the power of 5. Okay. The fourth root of 81 is 3, and the fourth root of 16 is 2. So we end up with 3 to the power of 5 divided by 2 to the power of 5. Oh. Okay. 3 to the power of 5 is 243, and 2 to the power of 5 is 32. Okay, so that's what this should be. Take a look at the solution. It's sort of messed that up a bit, but hopefully you get the idea. Okay. Next, finally, 27 over y cubed to the power of negative a third. So we could write this. Well, the negative sign there flips that 27 over y cubed, so we end up with y cubed over 27 to the power of a third. That 1/3, flower power roots, so it's the cube root, so it's the cube root of y, and the cube root of 27. I'm just going to write 27 to the third and y cubed to the third. Now looking at that bracket, we know that indice rule, we can multiply the indices. So 3 times a third, well that just leaves us with 1, this is y to the 1, or just y, because y to the 1 is itself. 27 to the power of a third is the cube root of 27. The cube root of 27 is 3. Okay. These are 3 examples. Check that you understand the examples, and we're going to practicing these skills in lessons. Okay. Video under 10 minutes, and I've covered the whole of indices for you.